Hello students, welcome once again. Today in this video we are going to discuss about one another property of fluid which is known as capillarity. Okay, so before understanding the meaning of capillarity, you must be aware with the terms of cohesion, adhesion and surface tension. So if you are clear with the terms of cohesion, adhesion and surface tension, you can very well understand the meaning of capillarity. So before understanding or reading the definition which is mentioned over here, let's just understand what is there in the diagrams which are given, where one diagram is of capillary rise and another diagram is of capillary fall. So here, as you can see, in capillary rise, one bucket is given or one vessel is given in which a liquid is filled, and that liquid is nothing but H2O, that is water. Okay, now if you can see that a zoom in picture has been taken of a certain area, okay, where there is a where the water and the glass is coming in contact with each other. Okay, so let's just move into the zoom in picture. Here you can see that the straight line depicts the face of a glass tube. Okay, while the curved shape represents the water. So here the water molecules and the glass molecules are coming in contact with each other. So here it is written that is H2O molecules, and the other one is written which is glass molecules. Now, as we discussed in our previous video or previous lecture, that cohesion is the attractive force or the intermolecular force which exists between the molecules of same liquid, right? And adhesion is the attractive force which exists between the molecules of different fluids. Okay, so here H2O molecules, in H2O molecules over here, there will be which force, cohesive or adhesive? It will be cohesive force, because the intermolecular attraction is between the molecules of the same fluid, while at the contact surface or where the surface interface, where the H2O molecules are coming in contact with the glass molecules, there will be which force? It will be adhesive force. Adhesive force means the force of attraction which is acting between the molecules of two different fluids. Okay, so here there are glass molecules and here there are H2O molecules. So here cohesive force in H2O molecules is less than adhesive force in glass molecules. So the glass which is made up of molecules have more adhesive force as compared to the cohesive force of H2O molecules. Okay, as a result of which what happens? As a result of which water particles will rise towards the glass tube. So it will rise upward, and there is a curve which is shown over here, upward curve. Okay, and at this curve or at this interface, the surface tension is existing. Okay, that is the interface between a glass tube and the water molecules, that is fluid. So here it is called as capillary rise because the liquid in the because the liquid in the glass tube will rise. Why it will rise? Because the cohesive forces in the water molecules are less than the adhesive forces in the glass molecules, as a result of which there will be rise in the capillary, and it is known as capillary rise. So capillary rise is a phenomenon which is occurring due to the cohesive and adhesive forces as well as the phenomenon of surface tension. Okay, now coming to the capillary fall. So if here you can see there is also a vessel in which a fluid is filled, but here the fluid is different. Here the fluid which is filled in the vessel is mercury. Okay, in this vessel it was water, while in this vessel it is mercury. So again zooming in the same picture, and there will be molecules of glass and there will be molecules of mercury as well, but here the case will be inverted. Okay, here the cohesive force in the mercury molecules will be greater than the adhesive force in the glass molecules, as a result of which what will happen? As a result of it, mercury particles or molecules will not rise towards the glass tube. So there is a bend curve you can see, okay, which is opposite to the capillary rise. So it is known as capillary fall. And one thing to be noted, that capillary fall generally takes place in mercury. Okay, so capillary rise phenomenon takes place in water, while capillary fall phenomenon takes place in mercury. And it is because that the cohesive forces, that is the intermolecular attractive forces between the molecules of mercury, are greater than the adhesive forces in the glass molecules. Okay, adhesive forces are present in the glass molecules because at the contact surface the glass molecules are coming in contact with the water molecules, and since the glass molecules are of less magnitude, or we can say that the intermolecular forces in glass molecules are less than the intermolecular forces in mercury molecules, the capillary fall action will occur. Okay, so now just let's read with the definition that what is capillarity. So it is defined as a phenomenon of rise and fall of a liquid surface. Okay, liquid surface in a small tube with reference to what? With reference to or relative to the adjacent general level of liquid when the tube is held vertically in liquid. So capillary rise or capillary fall is a phenomenon in which the liquid surface will rise or fall in a glass tube when it is placed vertically in liquid and it is relatively adjacent to the another level of liquid. Okay, so this was the capillarity, capillary rise and capillary fall. Capillary rise mostly occurs in water and capillary fall mostly occurs in mercury. Okay, because the intermolecular forces in water molecules are greater than the intermolecular forces in the glass molecules, and those intermolecular molecules of the same liquid, same fluid, are known as cohesive forces, while the intermolecular forces of the two different liquids are known as adhesive forces. Okay, so now let's see that how we can derive the what we can say expressions for the capillary rise and capillary fall, which you will use to calculate numericals. Okay, so here it is written expression for capillary fall. So first of all we will see that how the derivation or expression for capillary fall is achieved. Now here if you can see in this figure, then comparing it with the expression, let us say that this H is the depression in liquid which is caused due to capillary fall, and over here H is the rise in the water which has been caused due to capillary rise. So H is the height of water. This sigma represents what? It represents surface tension. Okay, and theta is the angle between the water molecules and the glass molecules. Okay, so let's see the expression for the capillary fall. So here if you can see that it is written that under equilibrium surface tension acting in downward direction is equals to hydrostatic force which is acting in upward direction. Okay, so here as you can see in the figure, the depression in the water which is caused due to capillary fall is kept in equilibrium. Okay, and anything will remain in equilibrium when the upward and the downward forces are neutralized. It means that the net resultant force is 0. So if the downward force and the upward force acting over here are equal, then the hydrostatic equilibrium, then the equilibrium will be achieved and this capillary fall is happening. Okay, so let's compare both the forces. So the surface tension is acting on downward direction and it is equals to the hydrostatic force which is acting in upward direction. Now surface tension which is acting in downward direction is sigma into pi d into cos theta. Okay, so sigma is the surface tension, pi d is the circumferential area of the tube, right? This circumferential area of the tube is denoted by pi d. Into angle is how much? Cos theta. So the surface tension acting in downward direction is equals to sigma into pi d into cos theta. Now it is equals to which force? It is equals to hydrostatic force. So hydrostatic force is nothing but pressure of intensity pressure into area. Students, you will learn this in detail in your second chapter, that is static fluids. So not required to go in detail right now. Okay, so hydrostatic force is equals to P into pi by 4 into d square. Intensity of pressure, this P is known as pressure intensity into area. So area is how much? Pi by 4 d square, and pressure intensity is nothing but rho into G into H. That you will learn. P is equals to rho GH. This is the formula you will learn in your second chapter of fluid statics. Okay, so instead, in case of P, I have written rho G and H. Now we want to calculate the depression of liquid. Depression of liquid H is nothing but we can also call this as capillary fall. Okay, the amount of mercury which has been fallen due to capillary fall action. So that H we need to calculate, and it is obtained by making subject H and taking all the other terms on the next side, that is 4 sigma cos theta upon rho GD, where theta for mercury and glass tube is fixed, which is 128 degree. So if you are calculating any numerical and if the value of theta is required to be taken, then it will be equals to 128 degree. Okay, clear? Okay, one important note you need to take care, that the value of capillarity depends upon 3 points, that is the specific weight of liquid, diameter of the tube, and surface tension of liquid. Okay, specific weight is the term which we learned in our previous video. If you remember, specific weight or weight density, W or gamma is equals to rho G. Okay, so the value of capillarity depends upon specific weight, diameter of tube, as well as surface tension of liquid. So this was the expression for capillary fall. You have to remember only two things, that capillary fall is possible. Okay, this much depression of mercury is possible only when an equilibrium state is achieved, and when the equilibrium state is achieved, when the forces acting in the upward as well as downward directions are in equilibrium. Okay, so we have done nothing, we just compared the forces which are acting in the upward and the downward direction, and from that we make the subject H and derive the formula. Okay, this is very simple. Okay, now going with the next expression for capillary rise. So this is the expression for capillary rise. Okay, so if you see in this figure, then capillary rise is the amount of water which is raised in the tube. Okay, so again we need to calculate the expression or derive the expression for this H. This was capillary rise H and this is capillary depression H. Okay, so here also under equilibrium, which forces are acting? Weight of liquid, which is denoted by H, is balanced by force at surface of liquid in tube through surface tension. Okay, what does it mean? It means that this surface of liquid is held or it is kept in equilibrium, or this forces due to this weight of liquid is balanced by upcoming which force is balanced by force in the downward direction, and that force is which force at the surface? It is surface tension force. So the weight of the liquid which is in upward direction is balanced by the surface tension force which is in downward direction. So for equilibrium we will compare this force, that is the weight of the liquid in the upward direction is equals to force of the surface tension force in the downward direction or at the surface. Okay, so weight of liquid H is balanced by force at surface of liquid in tube, and that force at surface of liquid is which force? Surface tension force, which is sigma. So for equilibrium state, weight of liquid of height h is equals to vertical component of surface tensile force. So we know that the formula of weight is mg, W is equals to mg, and this is again same sigma into circumferential area of liquid surface into cos theta. So circumference is pi d, cos theta sigma. Now mass is what? Density into volume. Okay, so density into volume into g. Now again volume is what? L into B into H, or we can also say area into height. Area into height is equals to volume, right? So here we are talking about area of what? Here we are talking about the area of tube. So area of tube is pi by 4 d square into H as it is. This is rho and this is G. So in place of M, that is mass, it is written density into volume. Again in place of volume, it is written pi by 4 d square into H, which is nothing but area into height. So rho into pi by 4 d square into H into G is equals to sigma pi d cos theta. Making H as a subject again, we will get this term 4 sigma cos theta upon rho g d. But here in case of capillary rise, cos theta is very small and it is nearly equals to theta, so it can be neglected. Hence the final formula will be H is equals to 4 sigma upon rho g d. So this is the final expression for capillary rise. Okay, and this is the final expression for capillary fall. Okay, and once again I am repeating the definition of capillarity, that it is the phenomenon of rise or fall of a liquid surface which is relative to the adjacent general layer of liquid when tube is held vertically in a liquid. Okay, so this was your capillarity and the derivations of capillary rise and capillary fall. Thank you. So students, after studying the theory of capillarity, which is one of the property of fluid, let us see its numerical. So here a sum has been given. I'll just read it out. Calculate capillary rise in a glass tube of 2.5 mm diameter when it is immersed vertically in first water and second mercury. Okay, so the theory which we saw, similarly a question has been given that a capillary rise is occurring in a glass tube of 2.5 mm diameter and it is immersed vertically first in water and second in mercury. So let us see that how the capillary rise occur in water and mercury. Okay, here you may have a question that in the theory portion we saw that in the mercury condition the capillary fall will occur. So that question will be solved at the end of your sum. Okay, so let's just start with the calculation. Okay, here it is already also given that take the surface tension for water as 0.0725 Newton per meter and take surface tension is equals to 0.52 Newton per meter for mercury when it is in contact with air. Specific gravity for mercury is also given 13.6 and theta is equals to 130 degree. See students, if the value of theta for mercury is not given, then by default we will take the value 128 degree as we studied in theory. But here in this question, as the value of theta is given, we will consider that value. Okay, so let's begin with the solution. Here the given data, first of all enlist the given data. So surface tension for water for mercury, diameter of tube which is 2.5 mm, hence it stands for 0.0025 meter, and specific gravity of mercury is 13.6 and theta is equals to 130 degree. Now we need to calculate capillary rise. So first of all we will calculate it for water, and it is given as capillary rise for water when theta is equals to 0 degree, as we saw in the derivation or theory of capillary rise. Now its formula is H is equals to 4 sigma upon rho GD. So 4, substitute the value of sigma which is 0.0725 divided by 1000 which is density of water into G 9.81 into diameter 0.0025. So it will provide us with the value of 0.118 meter which is equals to 1.18 centimeter. As the capillary rise or fall is always mentioned in millimeter or centimeter. So if your answer is coming into meter, you need to compulsory convert it into centimeter or millimeter. Okay. Now for mercury, our formula is H is equals to 4 sigma cos theta upon rho GD. Right, again substituting all the values, substituting theta is equals to 130 degree, value of sigma 4, density of now see here that you in question you have given the specific gravity of mercury which is 13.6. okay, so in order to obtain the density we need to multiply this term with 1000. okay, so specific gravity of liquid is given, and if we multiply that with the value of density, that is 1000 density of water, then we can get the density of that particular fluid. okay, in the capillary rise also here as you can see I am pointing it out, in place of rho you have written 1000. Why? It is also specific gravity into 9.81. okay, so density of water is 1000, that we know, but here density of mercury we don't know. We need to calculate the density of water, density of mercury, and that is specific gravity into density of water which is 1000. So specific gravity is for mercury is given how much? 13.6 into 1000. Here we know the specific gravity of water into 1000. So specific gravity of water we have studied, right? In the first lecture that I conducted, I have told you that the specific gravity of water is 1, because it is the ratio of weight density of a fluid to the weight density of a standard fluid. So here our fluid is water and standard fluid is also water. okay, so it will be 1, so 1 into 1000 will be equals to 1000, but here the specific gravity of mercury is different, that is 13.6. so 13.6 into 1000 will be the density of mercury. So 13.6 into 1000 into 9.81 into 0.0025. Here you can see that you are getting a negative answer, that is minus 0.004 meter, which is equals to minus 0.4 centimeter. Right. So this negative sign indicates that the capillary depression is occurring. Okay. Negative sign indicates that capillary depression is occurring, the capillary rise is not occurring. So if you are getting minus sign in your answer, then it is the indication that the capillary depression is occurring in the glass tube. Okay, thank you.